My screen is visible. Is it visible screen? The assignment? Anyone?
Yes, sir.
Okay. So today I will discuss the assignment 4 from the previous course. So it is the course number is MA49. So let's start with the first question. What is the first question? Saying that a function is convex if and only if its epigraph is a convex set. So this you have to say that it's true or false. So we will show that this is true. In fact, we will prove this. Here it means we have to prove that if a function is convex, then you have to show that its epigraph is convex set, and when the for converse, if the epigraph is a convex set, then the function will be convex. Okay. So what is the definition of the convex function? So convex function, this is convex function. It should satisfy f of lambda x plus 1 minus lambda y. This should be less than equals to lambda times f of x plus 1 minus lambda into f of y, where lambda belongs to 0 and 1, right? So this is the definition of convex function. And what is the definition of epigraph? So this is epigraph. How it is defined? So epigraph, this is a set. We will denote it by a p graph of f is all such points xy belongs to in R2 such that what is fx should be less than equals to y. So this is the definition of epigraph. So so this is a set. So if is convex, if and only this set is a convex set. So what is mean by convex set? Convex set. What is the definition of convex set? Suppose S is a set. Let S be a set. And if x and y belongs to S, then lambda times S plus 1 minus lambda y should belongs to S, where lambda belongs to 0 and 1. So then we call S to be convex. Oh, okay. So these are the definition. Now you have to prove that a function is convex if and only if its epigraph is convex set. Yes. So let's first do the converse part, this direction. So assume epigraph is a convex set. Epigraph of f is a convex set. So you have to prove that the function is convex. So what to prove? To prove f is convex function, right? So we will prove this by contradiction. We will prove this by contrapositive argument. So what? So means, so suppose, so what we will assume, suppose f is a, so we have to prove that f is a convex, so we will assume that suppose f is not convex. Suppose f is not convex function. not convex. So then what is the meaning of this? So means there exist x and y belongs to the domain of f and lambda belongs to 0 1 such that, so for convex this should hold, right? F of lambda x plus 1 minus lambda less than equals to lambda into fx plus 1 minus lambda fy. So this inequality should be reversed. F of lambda x plus 1 minus lambda x into y should be strictly greater than this. So this should hold, right? If f is not convex, means there exists x and y in the domain of f and lambda is 0 1 such that f of lambda x plus 1 minus lambda y should be strictly greater than lambda times f of x plus 1 minus lambda times f of y. So this will hold, right, if f is not convex. Now you have to we have to come up with some contradiction that epigraph is a convex set. You have to somehow you have to come up with this contradiction. So just take 2 points. So let's take peak x and fx, this, and y comma fy, let belongs to these two are epigraph of f. And we know that epigraph is a convex set, means that linear combination of these 2 points should be in the epigraph. And let me number this by 1. So from 1, what it is saying that from 1 we have what happened? So this, if you write in the linear combination, lambda x plus 1 minus lambda into y comma lambda of fx plus 1 minus lambda fy, this tuple does not belongs to, right, epigraph of f. Why this does not belongs to epigraph of f? Because what is the definition of epigraph? The image should be less than equals to the domain point, right? This is the definition of epigraph. This is fx should be less than equals to y. But what here is saying that as this does not, from 1 we have as f of this point, f of lambda x plus 1 minus lambda greater than lambda times fx plus 1 minus lambda fy, right? And epigraph is the definition should be this should be less than equals to this. So that's why, so we get that if these two x fx and y fy belongs to epigraph, then the linear combination does not belongs to epigraph. But what it is assumption that the epigraph is a convex set, right? Our assumption epigraph is a convex. So this is a contradiction, right? So this is a contradiction. So this is a contradiction to the fact that epigraph is a convex set. So our assumption is wrong, means f is a convex function, right? Because we have assumed that f is not convex and we have come up with a contradiction. So f is a convex function. So this proves the converse direction, right? Is this fine? This part? So now we have to prove the forward direction. So now we will prove this direction. So means what we have to prove? So assume f is convex function. F is convex. And what we have to prove? To prove epigraph is a convex set, right? So again we prove by contradiction. So assume that epigraph is not a convex set. So suppose epigraph of F is not a convex set. Means what? Means which imply that there exist 2 points x tx and y ty. Both are belongs to the epigraph of y, epigraph of F, and lambda belongs to 0 1, such that what happened, these two are belongs to epigraph, means fx should be less than equals to tx, right? And fy will also be less than equals to ty. And what happened? So these two epigraph is we have assume that epigraph is not convex. So if these 2 points belongs to epigraph, then the linear combination should not be. So and what happened? The linear combination lambda x plus 1 minus lambda y, comma lambda tx plus 1 minus lambda ty does not belongs to the epigraph of F, right? So this will hold, right? So we have assumed epigraph is not convex, means there exist 2 points such that these two belongs to epigraph, but their linear combination will not belongs to the epigraph of. So this is the meaning that epigraph is not a convex set, right? So we have write down the definition of epigraph is not convex set. Now we have to come up with some contradiction that f is a convex function. Now from here you can see that now look at this, f of lambda x plus 1 minus lambda y. What happened? This does not belongs to epigraph. So this does not belongs to epigraph, imply its image f of x, this should be greater than, right? So this will be by definition. This is the by definition of epigraph. This will be greater than lambda times tx plus 1 minus lambda times ty. And now you know that tx is greater than equals to fx, so lambda times fx plus 1 minus lambda, again ty is greater than fy. So we get what we get, f of lambda x plus 1 minus lambda is strictly greater than lambda times fx plus 1 minus lambda fy. So this is a contradiction that f is a convex. So what we will get, lambda fx means this. So f of lambda x plus 1 minus lambda y, this is strictly greater than lambda fx plus 1 minus lambda fy. This is strict because this inequality is strict, right? So that's why everything is strict. So which is a contradiction, which is a contradiction to the fact that f is a convex function, right? So what is the assumption? Means we have come up with a contradiction. So our assumption should be wrong. We have assumed that epigraph is not a convex set. So this is wrong, right? So what is the conclusion? So epigraph is a convex set. Epigraph of F is a convex set. Right? Is this fine? So what we have proved that AP is convex if and only if its epigraph is convex set. We have proved both the direction. So the statement is true. Right? So here it's also true. Any question with this? Yes. Okay, let's move to the next question. What it is saying? Fx is given by x square plus 3x minus 10, and given x0 equals to 0 is the starting point of the Newton's method. You have to find the second iterative steps of the Newton's method, right? You have to find x2 means the second iterative steps of the Newton method. So what is the iterative steps for the Newton methods general? So this is Newton's method. Iterative steps, what are these? Are xn plus 1 equals to xn minus f of xn by f dash at the point xn, right? Where f dash xn should be non-zero. So this is the iterative steps for the Newton's method. So x0 is given, this is the starting point, you have to find the x2. So use the iterative process. Using x0 we will find x1, then using x1 we will find x2. So what will be x1? So x1, put n equals to 0, so we get x1 equals to x0 minus, put n equals to 0, we get x1 equals to x0 minus f of x0 by f dash x0. So what is f dash x? Just compute it. What will be f dash x? Because fx is x square plus 3x minus 10, so f dash will be 2x plus 3. So f dash of x naught, so just put down it as x naught is 0, f of x naught means x square, put 0 at f, so 0, 0, it will be minus 10 by f dash 0, if you put you get 3. So what is this? 10 by 3, right? We get x1 equals to 10 by 3. Now we have to find x2 using x1. So what will be x2? x2 will be x1 minus f of x1 by f dash x1, right? So just write down what it is. It will be 10 by 3. What will be f of x1? Just compute f of x1. It will be, if you compute it here, f of 10 by 3, what you will get? You will get, it will be 100 by 9. Just compute it. I am just writing it down. Just check once. It will be 100 by 9. And f dash x1, f dash at the point 10 by 3, what it is? It will be 29 by 3. So these two will get 29 by 3. Then if you do this calculation, what you will get? So this will be 100 by 87. If you do this calculation, you will get 190 by 87. So we get x2, right? So this you have to find. So which answer is correct? So this is the second option, 190 by 87. So all other options are correct, wrong. Is this fine? Okay. So let's move to the next. Oh, this is similar. For the function, you have here the function only changes. Here the function is x square minus a, such that a is greater than 0. You have to find the Newton's iterative steps, general steps you have to find for this function. We know what is xn plus 1. We know the formula. This is xn minus f of xn by f dash xn, right? So you have to find the derivative of f. Just find the derivative of it will be 2x, right? So just put it down. Xn plus 1 will be xn minus f of xn means it will be xn square minus a. F dash xn it will be 2xn, right? For if xn is non-zero, just start with a point where the xn means first iterative or second iterative is non-zero. Start from a non-zero point, then it is well defined. So then it will be xn minus xn by 2 plus a by 2xn, right? So means this will be xn by 2 plus a by 2xn. Take out the half common. What you will get? Xn plus a by xn. Okay. So this is the Newton's iterative method. Xn plus 1 will be half of xn plus a by xn. So this we will got. So just check which answer will be correct. So this is the first option will be correct. Xn plus n, x of n plus 1 will be half of xn plus a by xn. Right? All other options are incorrect. So for 3, option A is correct. Okay, it's fine, right? Okay, let's move to the next question. Problem number 4. What it is given? Fx is given x to the power 4 minus 24x square plus 5x plus 7. You have to find the interval where f will be concave. Concave means if this is, because this is a polynomial, so this is a smooth function, so it's enough to check in terms of its double derivative, right? So if function is concave if its double derivative is less than equals to 0, right? So f will be concave, f will be concave if f double dash x is less than equals to 0 for all x belongs to some interval. So you have to find this interval, you have to find. So just compute the double derivative of f. What will be the f dash x? It will be 4x cube minus 48x plus 5. Now find f double dash x. It will be 12x minus 48, right? 12x square, sorry. So you have to check in which interval this will be less than equals to 0. So make it less than equals to 0. F dash x less than equals to 0 means 12x square minus 48 is less than equals to 0, or whatever, x square is less than equals to 4, means where x should lie, if x square is less than 4 then x should lie, so x should lie between this interval minus 2 to 2, right? Because if it is outside both minus 2 and 2, and then the x square will be greater than is 4. So x will be lie between minus 2 to 2. So in this region f will be concave. So f is concave in minus 2 to 2 in this interval. So just check which options will be correct. So first option is minus infinity to minus 2, so this will not be true. 2 to infinity, it is also not true. Minus 2 to 2, this is open. So if the function is concave in the closed interval, so it will be automatically concave in the smaller interval, right? So f is also concave, in minus 2 to 2, right? So we get third option is correct, and none of the above is again false. So we get the third option, minus 2 to 2, f is concave, right? Because function is concave in the whole region means it is concave in the smaller region also, right? So the third option is correct. Is this fine? Problem number 4. Any doubt? Okay. So let's move to the next. Okay, it's again the same question. You have to find the value of a for the function p, where it will be convex in the interval 0 infinity. So px, it's again a polynomial, x to the power 4 minus 2ax cube plus 5x plus 3. So you have to check, means for which values of a, p double dash x should be greater than equals to 0 in the interval 0 infinity. So you have to check p double dash x where it is greater than 0. Just differentiate it. P dash x, it will be 4x cube minus 6a x square plus 5. P double dash x, it will be 12x square minus 12ax, right? So you have to make these to be positive in the interval for x belongs to 0 infinity. So put it. So p double dash x should be greater than 0 for p to be convex on open 0 infinity, right? Or what is the meaning this? X square minus ax, this should be greater than 0, right? Or 12x, again common, x minus a, this should be greater than 0. And where x lies between 0 and infinity, right? X is always positive. So 12 is a positive number, x is also positive. So x minus a should be positive, right? So x minus a should be positive. For p to be convex. For p to be convex. So you have to check for which values of a, x minus a should be greater than 0. So for if a equals to minus 2, then, so if a equals to minus 2, then what happen? It will be x plus 2 and x is positive. So this is greater than 0 as x is positive, right? So for a equals to minus 2, this will be positive. So a equals to minus 2 is the correct, this is correct. For a equals to 2, just check what happened. If a equals to 2, so this is correct. If a equals to 2, we get x minus 2. Can this be always positive? So this may not be always positive, right? Because you can take x to be less than 2. Positive which is less than 2. May not always positive. May not be always greater than equals to 0 for x greater than 0, right? So this is the wrong option. What is the next option? A equals to 5. If a equals to 5, what happens? X minus 5. Can this be always positive? No, this is again, right? If x is less than 5, this cannot be always greater than 0. So this is not greater than 0 for all x greater than 0, right? So this is again false. So a equals to minus 2 is the correct option. So if we take a equals to minus 2, then p will be convex in the interval 0 infinity. So equals to minus 2 is the correct option. Is this fine? Okay. Let's move to the next one. It is question number 6. What it is saying? You have to find the area of the region enclosed by the two curves f and g. It's given fx equals to x and gx equals to x square. So fx equals to x in the interval 0, 1. and gx equals to x square. So just draw these two curves. It is 0 and it is 1. Fx equals to x, it is the straight line, this, right? And gx equals to x square, how this curve look like? This is the graph of x square, right? So this is a point 1, right? So you have to find the area of the region enclosed by these two curves. Means you have to find this region. To find. So this is F and this is G. Right? So how to find this? Because you know the integration of the curve F will give the region, the entire region below the curve F, and integration of G in 0 to 1 will give the area below the curve G. So to get the area this, we have to just subtract the area of F from the area of G. Then we will get this region, right? So suppose this is A. So name it by A. So A will be integration of 0 to A fx dx minus integration 0 to 1 gx dx, right? So this will give the area under the curve F, and this will give the area under the curve G. So if you subtract, you will get this, the shaded region A, right? So now put what is F. So this is 0 to 1 x dx minus what is this, 0 to 1 x square dx, right? Now just integrate it. So this will be x square by 2 from 0 to 1 minus x cube by 3, 0 to 1. So what happens? It will be half minus it will be 1 by 3. So what is the value? It will be 1 by 6. So area of the shaded region is 1 by 6. So the which option is correct? Option B. All other options are false. Is this fine? The area? How we have to find it out? Okay. Let's move to the next one. What? You have to find the average value of the function 3x square plus 2 on the interval 0 to 2. So find the average value, right? What is the average value of a function? So average value, average value of f is given by just in the interval. Suppose f is given this for general function. Suppose f is a function from ab to r, some interval ab to r. Then average value will be given by the length of the interval. What is the length of the interval AB? It is b minus a, right? And so you have to divide the length of the interval and just integrate from a to b. Integrate the function f from a to b and divide the length of the interval. So this will give the average value of f. So this is called the average of f. So you have to find the average of f in the interval 0 to 2. So here a is 0, b is 2. You have to find the average of f. So average of f, and what is the function? 3x square by 2. Fx is given 3x square plus 2 on 0 to 2, right? So average value of f on 0 to 2 is, it will be interval. What is the length of the interval? It's 2, right? 2 minus 0, it's 2, and integration from 0 to 2 fx dx. What is f? F is 0 to 2 3x square plus 2 into dx. You have to integrate it out. So what happens? It will be half. If you integrate this, you will get x cube plus 2x, right? From 0 to 2. So just put it down. What will be give the answer? So it will be half 8. It will be 8. 2 cube means 8 plus 4, right? Is this fine? So 12 by 2 means 6. So average value of f, what is? We get 6. So 6 is the average value of f in the interval 0, 2. So option 3 is correct. Right? Is this fine? Okay. So let's move to the next one. Question number 8. What you have to do this integration. So this is just simple integration. I is given by integration square root 40 minus 1 d dt, right? You have to integrate it. This is a indefinite integral, right? So this, how to do this? This is 40 minus 1 to the power half, right? dt. So what will be the integration? So this is 1 by 4 will be, and it will be x to the power n, it will be x to the power n plus 1 by n plus 1, right? So 40 minus 1 half plus 1 means 3 by 2 by 3 by 2, right? Plus c will be there. This will be some arbitrary constant. Right? C is constant. So what is this? So this will be 1 by 6 into 40 minus 1 to the power 3 by 2 plus c. So this we will get. So which option will be correct? Option A, right? So this is the value of the integration. 1 by 6, 40 minus 1 all to the power 3 by 2 plus c. Is it fine? Okay. Let's move to the next one. Here what you have to do, you have given that y equals to integration 0 to x square cos t dt. You have to find the y dash of x. You have to find the derivative of y. So how to do this? Here you have to use the Leibniz rule, because whenever it will be some kind of integral or and the limit is the function of x. Here it will be something. Yeah. Here it will be y of x, right? So this is this is y of x. Whenever these limits are in the functions of x, you have to use the Leibniz rule. So what is the Leibniz rule? Leibniz rule. Sorry. So what is the Leibniz rule? So suppose you have this, you have to differentiate this, where the integration like this, function of here a, it will be b, and suppose function is ft dt. So how to do this? Just put the function value f of bx, put the upper limit first, f of bx, and do the differentiation with respect to x, the ddx of bx minus, again what we will do, put the lower limit f of x and differentiate again x. So this is the Leibniz rule. So here also the ax is 0, 0 function, bx is x square, and this is ft is cos t. So use this Leibniz formula. So using this formula, what is y of x is given 0 to x square cos t dt, right? So what will be the y dash of x? So what you have to do? First you have to put this cos of x square. Now you have to differentiate x square with respect to x. It will be 2x minus, you have to put 0 cos 0, and now you have to differentiate 0, so it will be again 0, right? So this part will give the value 0, so it will get 2x into cos x square, right? So this is the derivative of y, 2x cos x square. So which option is correct? Option 3. So this type of integral, if you want to differentiate, use the Leibniz rule always. So this is the derivative of y, 2x cos x square. Is this fine? Okay. Now come to the last question. Here you have to again find the value of the integral of this 0 to pi by 4 1 plus cos 4x, right, dx. So how to do this? Just use the formula for 1 plus cos 4x, right? You know this formula, 2 cos square x equals to 1 plus cos 2x, right? You know this. So if you use this, what happens? So square root of it will be square root 2 into cos 2x, right, dx. Use this. And root 2 is a constant, so it will be come out of the integral. So it will be 0 to pi by 4 cos 2x dx, right? So what will be the integration of cos 2x? It will be square root to half, it will be sin 2x in the interval 0 to pi by 4. So it will be 1 by root 2 sin, if you put the value pi by 4, you will get sin pi by 2 minus, if you put the value, you will get sin 0. So sin pi by 2 is 1, sin 0 is 0, so you get 1 by root 2. So this is the value of the integration, 1 by root 2. So which option is correct? Option B. Is this fine? This one? Okay. So you have completed the week 4 assignment. Any question? Yes. Is this fine? Okay. Okay, then let's.
One
Yes.
time tell me
Yes. Hello.
first question, sir.
First question. Okay. Okay. Should I explain it again? Okay. So what it is saying that a function is convex if and only if its epigraph is a convex set. So what is the definition of convex function? If f of lambda x plus 1 minus lambda y, it should be less than equals to lambda fx plus 1 minus lambda fy, right? For lambda belongs to 0, 1. An epigraph, all the points where fx is less than y. This is called the epigraph of f. And convex set means if 2 points are in S, then their linear convex combination should be in S. So these are the 3 definitions. So now you have to prove. So just prove the converse direction. Just assume the epigraph is a convex set. Assume epigraph is a convex set. You have to prove f is a convex function. Okay. So we'll prove it by contradiction. So what we have assumed that F is not convex, means this inequality will be reversed, right? For convex it is less than equals to, but we get, so F is not convex means there will be 2 points in the domain for which this inequality will be greater than, right? So this is mean the F is not convex. We will get at least 2 points where for which this will be greater than f of lambda x plus 1 minus lambda y is greater than lambda fx plus 1 minus lambda y. So using this we will show that epigraph is a not convex set. Then we will get a contradiction, right? So for that what we will do, we are choosing 2 points from the epigraph x fx and y fy. Now we are taking the convex combination, this lambda x plus 1 minus lambda y into lambda fx plus 1 minus lambda fy. But from one you can see that f of this is greater than this, means this point, this is a point, right? This point does not belongs to epigraph, because if this will belongs epigraph, then this will be, by the definition, what is the definition? Xy belongs to epigraph if fx is less than y, right? So means f of this should be less than this, second means f of this should be less than this point. But what we will get from one, we get f of this is strictly greater than this. So means this point does not belongs to epigraph, right? So which is a contradiction. 2 points belongs to epigraph, but their convex combination is not in the epigraph, right? So this is a contradiction that epigraph is a convex set. So our assumption is wrong. What is our assumption? That F is not convex, means F is convex. Is the direction fine? Converse direction? Yes? Is it fine, this direction? Okay, let me explain the forward direction. So assume F is convex, you have to prove that epigraph is a convex. So we have again proved it by contradiction. We have assumed that epigraph is not convex, means this is not convex set. So we will get at least 2 points such that their convex combination is not in the epigraph. So you have taken these 2 points xtx, yty such that their convex combination is not in the epigraph, right? So this is the convex combination. But what this saying, this is does not belong to
Sir,
epigraph. Yes, yes.
sir, one time, sixth question will be repeat, sir. Sixth question, sir.
Oh, one is fine.
Sixth question, doubt, sir.
Okay, sixth question. Tell me. Tell me why. Why? This is the sixth question. Tell me why it is. What is the doubt? Yes.
Doubt me.
Yes.
Sir, the loop is how to draw, sir.
How to?
Draw, sir. How to area will be fine, sir.
Oh yes. What is the area of a functions? So suppose any function is given like this in the interval ab. So if you integrate this function, suppose this is h. So what is the integration of this? So this will always give the area under the curve, integration of a function. So this will be the, if this is the some s, so s will be given by this integration. So when you integrate f, so it will give the entire region. The entire region. If we, so this region. So suppose let me draw it here. Yes. If x is here f, so in the interval 0 to 1, so this will give the entire region. And for g is look like this, right? So g will give this region below the curve. So what is remaining? This one, right? So if you subtract the from the first one, second one from the first one, we will get this black region, right? Do you get it? Hello? Do you get it, Sanjay?
Yes, sir.
Okay. Is this fine? Any other
Yes, sir,
question?
that's fine, sir.
Okay. Any other question? Last sum. Oh, means the integration. Okay. Question number 10. This one. So you have to find the value of this integral, right? 0 to 4 by 4 integration of root square root of 1 plus cos 4x, right? So you have used this. What is 1 plus cos 2x? Cos 2x is 2 cos square x, right? So here it is given 1 plus cos 4x. So suppose this. So just I have cos theta, I am replacing it by theta, then it will be easier for you. 2 cos square theta. So take theta equals to 2x. Then you will get this, right? If you take theta equals to 2x, what happen? 1 plus cos 4x, it will be 2 cos square 2x, right? Now if you take the square root, if you take the square root, 2 will be, it will be, because it is cos square 2x, so it will be taking, after taking square root, it will be cos 2x, right? So you have to just integrate this function. Because root 2 is a constant, it will come out of the integration. Cos 2x is the only function. And what is the integration of cos 2x? It will be sin 2x, and because there is 2, it will be 1 by 2 will be divided. And now you have to evaluate in the interval 0 to pi by 4. Now put the pi by 4 here. So it will be sin pi by 2. 2 with 4, it will be gives 1 by 2. So it's sin pi by 2 minus, if you put 0, it will be sin 0. Right? And sin 0 is 0, sin pi by 2 is 1. So we'll simply get 1 by square root 2, right? Is this fine? Selva? Do you get it? Okay. Any other question? Okay. If everything is fine, then let's stop for today. We will again meet in the next week. Okay. Bye. Let me stop the recording.